Welcome to the next installment in my video lecture series in economics. And in this particular video lecture, I'm going to be taking a look at household behavior and consumer behavior in the Principles of Microeconomics course here at Rutgers University. This is Chapter 6 of Pearson's book by Case Fair and Oster. So some of the things that we hope to accomplish in this particular chapter is to gain an understanding of the budget constraint, what is the budget constraint, and how do we come up with the budget constraint, and in particular, what role does it play in household demand. So the budget constraint or the budget line is just going to tell us what we can afford to purchase given our income and the prices of the goods that we can purchase. We're going to also take a look at the utility maximizing rule. One of the things that economists assume is that consumers are utility maximizers. That is, they attempt to gain as much satisfaction as they can, is what is meant by utility, from the goods that they purchase. So they're constrained by the income and prices, so they try to gain the most utility they can based upon those constraints. We also want to take a look at the income and substitution effects. So for example, if we change the price of a product, let's say if we lower the price of one of the products that we're looking at, the substitution effect is what's going to occur is as that good decreases in price, people will substitute away from the more expensive good to the less expensive good. But also because income goes down, in essence what's occurring is a portion of what we see is that people's income is going up. As we'll take a look, we'll see how the opportunity set increases. So a portion of any increase in the demand for a product, or for most changes in the price of a product, any increase in quantity demanded can be broken down into the two effects of income and the substitution effect. And then we're also going to take a look at the factors that affect labor and savings decisions in households, i.e. we'll take a look at why the supply of labor looks the way that it does, and why it's possible for the labor supply curve to be backwards bending, i.e. that at much higher levels of income, people will have a tendency to choose to work less instead of working more. Under normal circumstances, as wages go up, the quantity of labor supplied goes up as well. But you can imagine under certain scenarios where people would have a dramatic increase in income and they would choose to work less because of that. So household choice in the input markets. So we're just going to review the determinants of household demand. Obviously, as we talked about previously, particularly in Chapter 3, the price of a product is an important determinant of demand, as well as your income. So income is going to be a determinant of demand. It's going to be an important component when we take a look at utility maximization. Also, the wealth that we have. So people who have, we talked about wealth previously as being the difference between your assets and your liabilities. Individuals who have greater accumulated wealth are going to have greater resources available to them so they can have a greater demand for products. We also take a look at the price of other products, right? We looked at substitutes and complementary goods. So that's going to be important to determining the demand of a particular product, is the price of related goods. Tastes and preferences, these are important. Some people prefer meat, other people prefer chicken, some people like seafood, some people have allergic reaction with seafood. So tastes and preferences vary among individuals. And also our expectations about the future, in particular what's our income going to look like, what's our wealth going to look like, and what our price is going to look like in the future. All right. If your expectation is, for example, let's say you're going to graduate in the spring, and your expectation is you're going to get a job and a good paying job, the expected increase in your future income can impact your demand in the present time. Same thing with wealth. Also with prices. If you expect prices to change in the future, that's going to impact your behavior in purchasing goods and services today. So the budget constraint, just remember that it's the limit that's imposed upon a household's choice or the individual's choices. So obviously, if we had unlimited income or unlimited resources, we would buy as much as we possibly can. But that doesn't occur for most of us. Most of us have a limit on our income. So we only have a certain amount of income that we can spend. And this limits us to what we can choose. We have a limited income, we have limited wealth, and we also have to deal with product prices. So all of these constrain the opportunities for purchases that are available to us. So the budget constraint maps that out. It maps out what's the limit on what we can purchase given prices and income. So this gives us an example, this table here, of different options available to someone. So this person, let's say, has $1,000 a month to spend. Option one, they can afford to pay $400 a month in rent, $250 a month in food, $350 in other expenses. So that is $1,000 total. So that is available to them. And we can go through all of these multiple combinations. B, the individual spends $600 per month on rent, $200 on food, and $200 on other expenses. So all of these are options that are available to them. And I have an error in this particular slide. Let me fix this before I continue. So we go to option C. The individual spends $700 a month on rent, $150 on food, and $150 on other expenses. Their total expenditures are $1,000, which means they can afford that combination of rent, food, and other expenses given their $1,000. And we have a fourth option, D. They spend $1,000 a month on rent, $100 on food, and $100 on other expenses. That means the option D costs $1,200 a month. And since they only have $1,000 per month after taxes, that is not available to them. So this is just mapping out different options to a particular individual, saying that option A in total costs $1,000, option B and C both cost $1,000. They are also available. This individual can afford to purchase options A, B, and C because it falls on or within their budget constraint or their budget line. Point D is not available because they only have $1,000 a month to spend, and option D entails expending $1,200 in income. So when I say the choice set or the opportunity set or your textbook, it's just what is available. What can a person afford given the prices of the goods we're looking at and their income that they have to spend. So the opportunity set is defined as that. What can this person afford to purchase given the prices and income that they are presented with? So let's take a look at putting together an actual budget constraint. So let's say this individual has $400 worth of income in a particular month or year, whatever the time frame happens to be, and we're just going to limit it to two different products that this individual is considering purchasing. All right. When we first started this course, and I talked about how we made some simplifying assumptions. One of the assumptions that we're going to make that simplify things is that we're only going to be talking about two particular goods here. So in our example, we're looking at the price of Thai meals and the price of the admission to a jazz club. So going out to get a Thai meal is going to cost $40, and the admission price to this particular jazz club is equal to $20. So the individual has $400, and here's the constraints placed upon them. They have $400 in income, and here's the price of the two goods that they're considering purchasing. So we can take that information and we can plot out all the possible combinations of Thai meals and jazz club visits for this person, given the constraints of income and prices of the two commodities. So for example, if this individual spends all of their money on Thai meals, So they have $400 available to them. The Thai meals cost $40 a piece. That means they can go out for a Thai meal 10 times in any given month. We could go to the opposite end of things, and we could take a look at if they spent all of their money on going to a jazz club. So going to a jazz club, and that's all they do. They don't go out to eat. They just go out to see jazz music for the month. You take that income of $400 and divide by 20, and that tells you that if they spent all of their money just going to this jazz club, they could go to the jazz club 20 times in any particular month. So points A and B map out the two extreme ends of only buying Thai meals and only buying jazz visits, going to the jazz club. If we connect points A and B, that gives us our budget constraint. Every single point that is on the budget constraint or the budget line is possible. It is affordable for that person. So if you're on the budget constraint, what that means is it is possible for you to afford the combinations of jazz club visits and Thai meals on that budget constraint. But also inside that budget constraint is also possible. Right? That just means you're saving some money. You're not spending your entire income. So it's still possible to purchase combinations of jazz club visits and Thai meals per month below the budget constraint. It just means that you're saving some money. You're not spending all your money. So the opportunity set is just bounded by the budget constraint. So the budget constraint is the upper limit, and every single combination on that budget constraint or inside the budget constraint is an opportunity to purchase for that individual. There are combinations of the two goods that are possible for this person to afford to buy during this particular time period. So we have point C. Also on the budget constraint, we have points A, B, and C are on the budget constraint. That means it's possible they can afford to purchase them, but it also means they're spending their entire income on these two goods. Point D is inside of the budget constraint. So it's still affordable. It just means that this individual is not spending all their money on these two particular items. And point E is not possible. Point E represents a combination of Thai meals and jazz clubs where the individual is spending more than $400 a month. And since they only have $400 a month to spend, they can't spend more than that on Thai meals and jazz club visits. So what we want to do is take a look at what equation represents the budget constraint. So if we just add our total expenditures on Thai meals to the total expenditures on jazz club visits, it must be less than or equal to our income. So it can't be greater than that. We can't spend more than our budget we're budgeted on those two items. So we can spend exactly the money we have budgeted or less than the money that is budgeted. Right? So the Thai meals were $40 a piece. So if we multiply that 40 to the number of Thai meals and we add that to the product of the $20 it costs for jazz visits and multiply that by the jazz visits in total, that amount has to be less than or equal to the $400 that's available for this person to spend. So if we assume that all of our income is being spent, here is what the budget line of the equation for the budget line is. All right, 40 times the amount of Thai meals plus 20 times the amount of jazz visits is going to equal our $400 budget. Remember, that means we're assuming that all of our income is being spent. So we can write that out in a general form, that the price of X multiplied by X plus the price of Y times Y is going to be equal to our income. So this is just writing this in a general form. We're just rewriting this in a general form. Our income is equal to 400. That's how much we have to spend. So that is I. And here's the total expenditures on Thai meals. And here's the total expenditures on jazz visits. So what is going to happen if we see a fall in the price of Thai meals. That means our budget constraint is physically going to change. So we have, and let me actually fix this because this animation should have been in there and it wasn't. So it's a wipe. Let me make sure I put it in here in the right spot. Let me save that and go back to this. My apologies again. As I told you in class, my keynote presentations for this are on a computer that died, and I haven't been able to get those presentations off of that computer yet. So I'm creating these all from scratch for this particular semester. Hopefully, after I get through some of these things and do some reviews on them, there'll be fewer and fewer errors in them. So here's our original budget constraint. We have our income, 400, the price of Thai meals is 40, and the price of jazz club admissions is 20. So price of Thai meals is equal to 40, the price of jazz club admissions is equal to $20. So that gives us our budget constraint and our opportunity set. Let's see what happens to the budget constraint. We want to see what's the impact of a change on a price on the budget constraint. So let's assume that the price of Thai meals falls to $20. That means we can afford to purchase more Thai meals every single month. It doesn't impact the total number of jazz visits, right? We can still only go to the jazz club 20 times because the price of jazz club admissions has remained the same. But because the price has fallen, what happens is our budget constraint is going to be shifting outward to represent the fact that now we can afford to buy more Thai meals every month. So realize that changes in the price are going to change what the budget constraint looks like. In particular, if you change the price of any of the goods that we're talking about, the slope of the budget constraint is going to change. So you can see that by lowering the price of Thai meals, that the price of the new budget constraint, the slope of the new budget constraint has gotten flatter. So with that lowering of the price, what we end up with is now we can afford to buy 20 Thai meals every month if we spend all our money on Thai meals. And this lighter blue section here represents the increase in the opportunity set caused by the fall in the price of Thai meals. So under the original price, this darker blue area was our opportunity set. With the fall in Thai meal prices and the halving of it, now we can purchase twice as the amount of Thai meals per month if we spend all our money on Thai meals. And that lowering the price increases the opportunities that are available for us to purchase Thai meals and jazz club visits per month. So realize that what we went over, we showed that the budget constraint is a function of income and prices. If we change the price of a product, we're changing the budget constraint. We're going to have a brand new budget constraint because of that. And as the price fell of Thai meals per month, that increases the maximum amount of Thai meals that we can purchase in that month because of the lower price. So we go from point A to point C, reflecting that decrease in the Thai meal prices. And this gives us an increased opportunity set due to the fact that the price of Thai meals has fallen. So the next part that we're going to take a look at is the notion of utility. And utility is just, for an economist, a measure of satisfaction. All right, so if you purchase a slice of pizza and you eat that pizza, you derive a level of satisfaction from the consumption of that particular item. So when we're saying utility, you can think of it or use a shorthand of saying satisfaction. So utility is a measure of satisfaction. So again, utility is a satisfaction a product yields. So these are some of the definitions that we're going to be using, and these are the terms that we're going to be using. So I want to make sure that you all have a good understanding of these terms. So utility is the satisfaction that a product yields. All right. Total utility is the total satisfaction a product yields. So for example, if I eat 5 slices of pizza, my total utility would be how much utility I get from consuming 5 slices of pizza. All right. Marginal utility, on the other hand, as it says here, is the additional satisfaction gained by the consumption or use of one more unit. So, for example, if I had consumed 5 slices of pizza, let's say I was very hungry, total utility is the utility that I get from consuming 5 slices of pizza. Marginal utility would be how much utility I got from consuming the first pizza, and then I would have marginal utility from consuming the second pizza, and then I would have marginal utility of consuming the third pizza, the fourth pizza, and the fifth pizza. So the marginal utility is how much your utility increases by consuming one additional unit. And one of the things that you can think of this is that total utility is the sum of the individual marginal utilities. So, for example, the total utility of 5 pizzas is equal to the marginal utility of each individual slice of pizza, slice 1, 2, 3, 4, and 5. If you add those marginal utilities together for each of those slices of pizza, you get the total utility from all 5 slices of pizza. So it's important to be able to distinguish between that, because we're going to use this concept of marginal analysis of additional times as the course goes along. So it's very helpful that if you can understand it at this point, it'll be helpful when we use other different types of marginal analysis moving forward for the course. And lastly, the law of diminishing marginal utility. What happens is as you consume more, your marginal utility is positive, but it gets smaller and smaller and smaller. So the example I always give is, let's say you went out for a bicycle ride on a really hot and humid day. Okay, and you went for, let's say, a 7-mile bicycle ride, and you get home and you want to get a glass of water to drink. Generally, what will happen is that first glass of water is going to be very satisfying to you. It's going to give you a high level of utility because you've sweated a lot, it's hot outside. All right, that cold glass of water is going to give you a great deal of satisfaction, the first one that you consume. At some point, as you consume additional glasses of water, the utility you derive from those glasses of water is going to get smaller and smaller and smaller. So, for example, let's say I did that and I drank 3 glasses of water when I got home. The third glass of water is going to yield less utility than the first glass of water. That first glass of water will be incredibly refreshing and satisfying. The third glass of water, less so. So realize that holds for all goods, that as you consume more of a good, the utility you derive from each successive unit gets smaller as you consume more. So here we're going to have a table that gives us how we can derive marginal utility from total utility. So you might be given a table that tells you here's the consumption of a particular good, here it's trips to a club, and you'll be given the total utility for example, there's the total utility from 1 visit to a club, here's the total utility for 2, here's the total utility for 3. You will be given the total utility for the trips to the club, and you should be able to derive what the marginal utility is. So there is no marginal utility for 0 trips to the club, because remember, total utility is the change in total utility as you increase the consumption of a particular item. Since we're not changing, we're not going from 0 to 1, we're at 0 and we're staying at 0, there is no change in the number of trips we're taking, and there's no change in the total utility. So we need to have incremental increases in the number of trips to derive what the total utility is. So if we have no trips to a club, we're not going to get any satisfaction from going to a club because we didn't go there. There's no utility from going to a club when you don't actually visit the club. But our first visit to the club yields 12 units of total utility. That means that our total utility increased from 0 to 12, right? We had 0 club visits, which gave us 0 units of utility. We went to the club once, and our total utility increased by 12 units. So the marginal utility of that first trip to the club is equal to 12. It's 12 minus the 0 level of unit, the 0 units of total utility from not visiting the club. So what we're doing is we're taking incrementally as we increase the trips to the club, how much does our total utility increase? So when we go from 0 to 1, our total utility goes from 0 to 12. The increase is 12 units. And we can do that for each successive increase in the trips to the club. So if we go to a club a second time, our total utility is equal to 22 units for 2 visits to the club. When we go from 1 to 2, the first trip to the club yielded 12 units of total utility. The second visit, our total utility goes to 22. Therefore, the second visit caused our total utility to increase by 10 units. So the marginal utility of the second trip to the club is equal to 10. It's 22 minus 12. And we can continue along. If we go to a third visit, our total utility goes from 22 to 28. That's a 6-unit increase in total utility caused by the third visit. And we can do that for every single one. So when we go from 3 to 4, total utility goes from 28 to 32. So our total utility increased by 4 units when we increased the number of visits to the club from 3 to 4. And we can continue that for every single additional combination of trips to the club. So all we're looking at is we increase the number of trips by 1 unit. How much does total utility increase? So we can map out what total utility looks like for this person. So we can take the information from the table that we were given and graph out trips versus total utility to see what the total utility curve looks like. And if we map out all those different points and graph them, that gives us what our total utility looks like. So if we take the data that's available in the total utility table and we graph trips to the club versus total utility, that will give us our total utility curve. So realize it has that shape, it's upward sloping, but the slope of it gets smaller and smaller as the number of trips to the club increase. So you can see here that it's fairly steep, but it's getting flatter and flatter and flatter as we increase the number of trips to the club we take. Okay, that's the principle of decreasing marginal utility. So you can see that as we go from 0 to 1, marginal utility is equal to 12. When we go from 1 to 2, marginal utility is equal to 10. So all we're doing is we're doing the same thing that we did in the previous slide, except we're looking at it graphically as opposed to looking at it in a table format. And we continue along, and you can see we keep getting the marginal utilities here. As we keep incrementally increasing by 1 unit, we're taking a look at how much our total utility is increasing with a 1 unit incremental change to the number of trips to the club, and this yields our marginal utility. So now we can take that information and we can graph out what marginal utility looks like. So we're going to be taking and using the number of trips to the club and graphing that against what the marginal utility looks like. So here, this is just the information from the table that we had. So all we're doing is graphing out trips to the club against marginal utility. And as you can see here from that data, we have our marginal utility is declining, which gives us that principle of that notion of the principle of decreasing marginal utility. That as you consume more and more of a particular product, you're going to get less and less additional satisfaction from consecutive increases in consumption of that particular product. Now, one of the things that we want to take a look at is that we want to use this to illustrate the principle of utility maximization. So again, one of the things that you're going to need to do is to calculate marginal utility when you're given total utility. All right, so we go from 0 beers to 1 beers, total utility is equal to 1 and marginal utility is equal to 1, because when we consume nothing, no beer, we get no utility. As soon as we consume that first beer, our total utility increases. So for the first unit of anything, total utility and marginal utility are equal to one another. And we can go through and do that. So we go from 12 to 22, marginal utility of the second beer is equal to 10. We go from 22 to 30, Margin utility there is equal to 8. 30 minus the 22 gives us the 8. And we can keep doing that for each successive unit. When we're going to be doing utility maximization, what we want to do is take a look at the marginal utility per dollar spent on that particular item. So all we're going to do here is take the column in marginal utility and divide by the price of that particular product to give us that. So if beer is equal to $2, all we need to do is take this column, the marginal utility column, and divide by the price of beer, which is equal to 2. So 12 divided by 2 is equal to 6. 10 divided by 2 is equal to 5. 8 divided by 2 is equal to 4. And we keep doing that for that entire column. So that gives us the information. This is important information because we will be using this to as part of the utility maximizing condition that we're building towards. So this is a piece of information that we are going to be using as part of utility maximization. And we can do the same thing for pizza. So for pizza, we will calculate the marginal utility. So the first pizza, the marginal utility is equal to 10, right? Total utility and marginal utility are equal to one another for the very first unit consumed. And then we can go through and calculate that for every single successive unit. When we increase our pizza consumption to 2 from 1, total utility increases from 10 to 18. That gives us marginal utility of 8. When we go from 2 pizzas to 3 slices of pizza, all right, our total utility goes from 18 to 24. That yields 6 units of marginal utility. We go from 24 to 28 units of total utility. When we go from 3 slices of pizza to 4 slices of pizza, that gives us 4 units of marginal utility, and so on. Now, once you are given the price of pizza, let's say a slice of pizza is equal to $1, then we just take this column and divide by the price of pizza. So 10 divided by 1 is equal to 10, 8 divided by 8 is equal to 8, 6 divided by 1 is equal to 6, and so on. Now, for utility maximization to occur, the marginal utility per dollar has to be equal to one another. So once you go through that table and calculate the marginal utilities per dollar for the 2 goods, you want to find the combinations that the marginal utilities per dollar are equivalent to one another. So we want the marginal utility of beer divided by the price of beer to be equivalent to the marginal utility of pizza divided by the price of pizza. And in our instance here, it is where we consume 1 beer and 3 slices of pizza. This will maximize the utility of this individual. When the marginal utilities per dollar are equal to one another, that is the condition that satisfies utility maximization. So if you're ever asked a question where, like at the beginning, you're just given the total utility and you have to calculate marginal utility and then marginal utility per dollar, this marginal utility per dollar column is telling us which of the combinations of beer and pizza are maximizing utility. Where the marginal utility of beer divided by the price of beer is equal to the marginal utility of pizza divided by pizza, that is the combination of beer and pizza that maximizes utility for that individual. So here is another combination, right? So 3 beers and 4 slices of pizza also maximizes utility for that individual. So we originally had a combination where 1 beer and 3 slices of pizza. Now another combination, 3 beers and 4 pizzas, is another possible utility maximizing combination. And lastly, you can see that 5 beers and 5 pizzas, the marginal utilities per dollar are equal for that as well. So there are multiple of these that you will see or possibly see on any particular question where the principle holds. The thing that we haven't included is how much money that we have to spend. So even though the principle of equal marginal utilities per dollar holds for multiple combinations of beer and pizza, the final determining factor is how much money that you have to spend. That's the constraint that is being placed upon you when picking the combination of beer and pizza that is going to maximize your utility. All right. So here is a demand for Thai meals in any particular month. And as you can see here, let's assume that we start at $25 per Thai meal, and the individual purchases 5 Thai meals per month. Okay? The reason being here is if we take a look at this particular demand curve, that remember, if the price falls to 15, this will induce the person to purchase more. What that is telling us is that each consecutive meal past 5, or any increase in the meal past 5, means that those additional Thai meals are yielding less and less utility. And the only way that this person can be induced to buy more Thai meals is for the price to be lowered, because the utility of each of those additional Thai meals is less. So the principle of the principle of diminishing marginal utility is a reason why one of the reasons why the demand curve is downward sloping. That because as we consume more of a particular item, the utility we derive from that item decreases. The only way people can be induced to purchase more is for the price to fall. And then it makes sense for them to pay less because they are getting less utility for that particular item. The income and substitution effects. These are very important concepts. So make sure you remember that if we see a change in consumption due to the change in the price of that particular commodity, there are 2 different effects at play. The substitution effect, i.e., let's say I lower the price of beer, people will purchase more beer because it's cheaper relative to other items that are out there. So a portion of what you are seeing in the increase in the quantity demanded when price falls is a substitution away from other items to that item because it's relatively less expensive compared to those other items. But by lowering the price, we are increasing the opportunity set, which in essence is the same thing as increasing income. All right? So realize that if you see an increase in quantity demanded due to a lowering of the price, the increase in quantity demanded could be accounted for by substitution, the substitution effect, and the income effect. All right, so that's exactly what is stated here. I took this right out of the textbook. All right, so the price cut makes you better off. You can buy the same amount of the price falling, and you have some leftover income. All right, so you feel richer due to the fact of that price decrease. So there's the income effect is that the lowering of the price makes you feel as that you have extra income left over when you're purchasing that specific amount. So, for example, I was buying 10 restaurant meals a month, and they have a special during the month that lowers the price by 50%. I can buy twice as much. If I purchase the same amount, I have additional opportunities available to me, which feels like I do have extra income left over. So a portion of that decrease in the price is going to be decrease in the price that causes the increase in quantity demanded. A part of it is accounted for in this income effect. The substitution effect is the fact, as I said previously, that that product is less expensive relative to others. So when that special where the Thai meals are 50% off, that means I can purchase twice as many of them, I'm going to purchase more Thai meals because it's less expensive relative to the other things I could purchase. So I'm going to substitute away from purchasing other items and buy more Thai meals because the Thai meals are less expensive relative to the other things that I can purchase. So realize that. So we have the income and substitution effects of a particular price change. So when prices fall, household is better off because their income, they can purchase more items because of that. So their real income, their purchasing power has increased. That causes an increase in income, which is the income effect, and the household buys more. As the prices fall, the opportunity good of purchasing that good decreases, so we substitute towards that item and we buy more. When prices rise, households are made worse off. Their opportunity set is lower. It means that their real income, the ability to purchase, has declined. So this is the income effect. They feel as though their income is falling, so the household buys less. As the prices rise, the opportunity cost of buying that good also increases. So they will substitute away from the good that increases in the price, and households will buy less. Household choice in input markets. So this has to do with the labor supply decision. So we have two labor supply curves. All right. One that is upward, is positive. It's upward sloping, right? And then we have a downward sloping supply curve, i.e., sometimes economists will refer to this as backwards bending. This is the standard supply curve. All right. And in this, as wages go up, people will supply more labor. I mean, it makes sense if you're making $5 an hour and then you get offered a job at $15 an hour, you'd be willing to work more hours per week because of that, the fact that you're getting paid more. So what happens is you will substitute away from leisure. All right, so we're taking a look at the labor-leisure trade-off. As the wages you get paid goes up and you work more, you're substituting away from leisure, i.e. your free time, and that is the effect that is dominating. The fact that you're going to substitute away from leisure time and substitute work time for that. However, as you can imagine a scenario that as wages go up to a high level, some people might choose to work less. Okay? Let's say you were making $15 an hour and you got a job making $150 an hour. All right? So let's say at the $15 an hour you were working 40 hours per week, you were making $600. You could make the same amount of money working 4 hours per week at $150 an hour. All right? That is where the income effect dominates, and that causes the supply curve to be backwards bending. That is, income goes up past a certain point. What happens is people are making more money, so now they're going to substitute leisure for work. So realize that sometimes you'll see things, especially if you take any upper level courses where they talk about the backwards bending labor supply curve. It's at the initial stages of wages. People, as wages go up, they're going to supply more labor, i.e. they're going to substitute work for leisure because the opportunity cost of not working is increasing. But at some point, as wages go above a certain level, you can imagine a scenario where somebody will actually have a dramatic increase in their income and choose to work even less. So that means the income effect is dominating that. Now this is the appendix, and this is probably the most important part of this particular chapter. So make sure that you review this and you understand this, because this course is a prerequisite for intermediate microeconomics and some upper level economics courses, so it needs to cover this for students to be well prepared for those intermediate courses. So indifference curves. One thing to simplify things, or we're going to restrict our analysis to only positive goods that yield positive marginal utility. We're not going to be looking at anything where consuming more decreases our total utility. We're only going to be looking at quote unquote things that are considered goods versus bads. Okay, a good is something that yields positive marginal utility. A bad is something that yields negative marginal utility. So we're going to restrict our analysis to goods that yield only positive marginal utility. All right, we're going to need to know this term, marginal rate of substitution, and that's the rate that households are willing to substitute goods X and Y. All right, and it is measured by the marginal utility of good X over the marginal utility of good Y. And that we are rational individuals, that we have the ability to choose among goods and services. We can say, I prefer A to B, or I prefer B to A, or A and B are identical to me. So basically what we're saying is that consumers are rational and they can make rational choices. And that's the final point there, that we're assuming, the assumption that we're making is consumers are rational. The indifference curve, if we're going to be using an indifference curve, we need to know what indifference curves are. All right, an indifference curve represents the combinations of two goods that yield the same utility. So if we have an indifference curve on a graph and points are on the same indifference curve, those combinations of goods that are represented by those points, if they're on the same indifference curve, they yield the same utility. So if point A and B and point C are on the same indifference curve, the combinations of goods represented by A, B, and C all give the same level of utility. So the reason why it's called the indifference curve, because you would be indifferent between points A, B, and C. If the combination represented by A yields 40 units of utility, and the combination of goods represented by B yields 40 units of utility, you are indifferent between the two because they yield the same level of utility. So let's take a look at what indifference curves look like. So here's 1 point. So we can purchase this amount of good Y and this amount of good X. We can do the same thing here. So all these points are just representing different combinations of good X. The reason we're referring to good X is this is the X-axis and we're calling this good Y, it's the Y-axis. It makes it easier for students to remember that marginal utility part that we were talking about previously. And we have another combination, B. And if we have a line that connects all three of those points, these points here all yield the same utility because they are on the same indifference curve. So make sure that you remember that if points are on the same indifference curve, the combinations of goods that are represented by those points, what they mean is that all of these points yield the same level of utility. That's why they're on the same indifference curve. So this indifference curve might represent 40 units of utility. So combination B, combination C, and combination A all yield the same level of utility. The thing to remember is that the slope of this line is the change in Y over the change in X. And that is the marginal utility of X over the marginal utility of Y. So it's negative the marginal utility of X over the marginal utility of Y. So make sure you remember that what the slope of the indifference curve is equal to. Because we're going to be using that with the budget constraint to show that principle of equal marginal utilities per dollar. So remember that the difference curve is downward sloping and it's a curve like that. Any points on the same indifference curve yield the same utility, and that the slope of the indifference curve is negative the marginal utility of the good on the x-axis divided by the marginal utility of the good on the y-axis. So here is our original indifference curve, but we can have multiple indifference curves on here. Right? We have indifference curve 0, indifference curve 1, and indifference curve 2. Your book refers to this as a preference map. Sometimes I refer to it as the indifference curve map. Okay? So just realize that technically there are infinite numbers of indifference curves in this particular space here. because all these indifference curves represent different levels of utility. So let's say this one represents 40, this indifference curve represents 50 units of utility, and this indifference curve represents 60 units of utility. All right? But that also means that there's an indifference curve that represents 41, 42, 43, 44, 45, 46, all of them in there. There's also a difference curve that represents 40.5, 40.4, 40.3. So there are infinite numbers of indifference curves represented in this preference map. The thing that you really need to remember is this point here, that the further the indifference curves go from the origin, the higher the level of utility. Make sure you remember this. So what we can say here is that the utility associated with the difference curve 2 is greater than the utility associated with the difference curve 1. So as we move further away, the utility from the indifference curves increases. So the further you move in this direction here, the higher the utility that is yielded by the combinations on that particular indifference curve. So here we have our budget constraint, our budget line. All right. So we're just reviewing what we went over with the budget constraint. And in order to get this, remember, if we want to know the maximum amount of units of Y we can consume, we just take the income we have available to us and divide by the price of Y. And that tells us how much we can consume if we buy nothing but Y. And if we want to know what's the most we can consume of X, if we spend all our money on X, we take the income that's available and we divide by the price of X. All right? So that gives us the two extreme ends, and if we connect those 2 points, that gives us our budget constraint, and the opportunity set is the shaded area inside of the budget constraint. So here's an original indifference curve. So indifference curve 0, and it intersects the budget constraint on points A and points B. So what we can say about point A and point B is that we can afford to purchase these, right? They both reside on the budget constraint, and since they reside on the budget constraint, they are both affordable. All right? So A and B are affordable. This person could afford to buy the combination represented by both A and both B. I can draw another indifference curve that is just tangent to the budget constraint. And that yields us point C. So that is where indifference curve 1 is tangent to the budget constraint. So point C is also affordable. It's on the budget constraint. I can afford to purchase, or this individual can afford to purchase point C. And I can draw in a third indifference curve 2. Point D is not affordable. Point D is to the exterior of the budget constraint. Since the budget constraint represents the maximum amount of combinations, the combinations that we can afford to purchase, all right, that is the most that we can afford to purchase. The budget constraint, this is the limiting factor on what we can afford. Since point D is outside of that, we don't have the income to purchase the combination represented by D at the particular prices that we have. Now, if our income goes up, we might be able to afford this. Or if the prices of Y or X decrease, we might be able to afford that combination at some point in time. But at the present time, we don't have the income to purchase that. Now, why we want to take a look at, we can exclude point D for utility maximization because we can't afford to purchase the combination represented by point D. So if we take a look at points A, B, and C, we want to take a look at these and say, well, what's the difference between A, B, and C? Or which ones are preferable, or which one maximizes our utility? If you remember, the further the indifference curves go from the origin, the higher the level of utility. So the utility associated with point C is greater than the utility associated with point B. points A or point B, because point C is on an indifference curve that's further from the origin than points A and B. Points A and B are on indifference curve 0, and point C is on indifference curve 1. Indifference curve 1 is further from the origin, therefore the utility associated with the combination represented by point C is greater than the combinations represented by points A and B. So point C is where utility maximization occurs. We can afford to buy A and B, but our purpose is to maximize our utility, and we can move from point A or point B to point C, spending the same amount of money. We're on the budget constraint, so the amount of expenditures is the same, but we'll get higher levels of utility at point C because indifference curve 1 represents higher utility relative to indifference curve 0. So if we know that the slope of the indifference curve is negative the marginal utility of good X divided by the marginal utility of good Y, and we know that the slope of the budget constraint is negative the price of X over the price of Y, if we set them equal to one another, i.e. to where the indifference curve is just tangent to the budget constraint, this is the utility maximizing condition. This can be rewritten as the marginal utility of X over the price of X equals the marginal utility of Y over the price of Y. So now you know, when we go back to that table where we were calculating the marginal utilities and dividing by the price of that particular product, and then selecting the combinations where the marginal utilities per dollar were equal to one another, that is the principle of equal marginal utilities per dollar. So this is to illustrate to you that that number was just not picked out of thin air. There was a theoretical underpinning for coming up for the principle of equal marginal utilities per dollar being the utility maximizing combination, or the utility maximizing condition. So we can use this information from the using indifference curves and budget constraints to derive a demand curve. So we're going to assume that this individual is maximizing their utility, and we're going to use indifference curves and budget constraints to derive why the demand curve is downward sloping. So we have our indifference curve that's just tangent to the budget constraint. This gives us the amount of X that's being purchased given our level of income and the price of good X. We're going to keep income constant, but what we're going to do is lower the price of X and see what happens to the utility maximizing amount of X we get. So if we lower the price of X, we're going to be able to afford to be able to purchase more of good X. So the budget constraint is going to rotate outwards in this direction. So if I lower the price, the budget constraint rotates outward, and now we have a new utility maximizing combination of good X. So by lowering the price, the utility maximizing amount of good X increases. So the price of X falls, the amount of X demanded increases. And we can do this a third time. We can lower the price of X a third time. So now we have a budget constraint representing a further decrease in the price of X. So now we have a new utility maximizing combination of goods Y and X, and the utility maximizing amount of X increases. So as we lowered the price, the utility maximizing amount of X increases. We lower the price again, and the utility maximizing amount of X increased again. So as we lowered the price, quantity demanded increased, which is exactly the law of demand, that there's an inverse relationship between price and quantity demanded. So I just wanted you to realize, well, number one, as I said, this course is a prerequisite for upper level economics courses, and this really needs to be covered in the course. It really has to, for this course to function as a prerequisite for intermediate, micro, and the upper level courses. But I also wanted to show you something theoretical that a lot of times people say, well, in theory that's wonderful, but in the real world that doesn't work. Well, this particularly works because this theory of utility maximization, budget constraints, and indifference curves can be used to show that there's an inverse relationship between price and quantity demanded, and that is the law of demand. So we can use this theoretical construct to actually prove that the demand curve should be downward sloping, and that the law of demand is that there's an inverse relationship between price and quantity demanded.